Hello everyone. Today we are going to have a session on energy estimation. Before entering into the topic, we should know what is energy. Energy is the ability to do work. The food what we are consuming is burnt inside our body and releases energy. The energy released can be transformed into different forms of energy such as chemical energy, thermal energy and mechanical energy. These energies are helpful to do various metabolic reactions inside our body, and also it helps to do various physical activities like walking, swimming, sitting, jogging, what all the physical activities we will perform. These energy will help to do that physical activities. Then we can see the unit of energy. Usually, the energy value of food is expressed in kilocalories. 1 kilocalorie is defined as the amount of heat energy required to raise the temperature of 1 kg of water by 1 degree centigrade from 14.5 degrees centigrade to 15.5 degrees centigrade. This is nothing but if you take 1 kg of water, how much heat is required to increase the temperature by 1 degree centigrade comes as the kilocalories. There are two types or two different calorimetric methods which is used to determine the energy value of food. One is direct calorimetry and another one is indirect calorimetry. In the direct calorimetry, the instrument used is bomb calorimeter. This bomb calorimeter works on the principle of the direct calorimetry. This will help to determine the energy value of foods. The next one is the indirect calorimetry. The instruments like Benedict's oxycalorimeter will helpful to determine the energy value of food by indirect calorimetry. In this session, we are going to see about the direct calorimetric method, that is the instrument which comes under the direct calorimetric method is bomb calorimeter. So, before entering into the bomb calorimeter, let us first see the principle behind this direct calorimetry. The chemical changes occur when carbohydrate or fat is oxidized during respiration in the body. So, whatever the chemical changes occur, if you take any food in the form of the carbohydrate or the fat, with the help of the oxygen, that will get burnt inside our body and that will produce some chemical changes inside the body. The same chemical changes occur when the food is burnt in the air also. That is, when the food is burnt in the bomb calorimeter also, whatever the reactions happening inside our body, that with the help of the oxygen supplied into the bomb calorimeter, the changes will take place inside the bomb calorimeter. The amount of energy released or expended is measured by the heat produced. Now let's see the determination of energy value of food by direct calorimetric method. The amount of energy released from foods can be obtained by measurement of heat produced when food is burnt in air. When the food is burnt with the help of the oxygen, then the amount of heat produced during that burning will converted into the energy. This bomb calorimeter works on the principle of the direct calorimetry. Now let us enter into the bomb calorimetric method. This outer layer is called as the insulating jacket, and inside that insulating jacket, this is called as the bucket. This bucket usually contains 3/4 of the water. This bucket should contain 3/4 of the water, and inside that bucket, this one is called as the bomb, steel bomb, heavy steel bomb which is placed inside the bucket. And inside that steel bomb, you will have this crucible-like structure. That is, this the food which is measured should be placed inside the crucible. Then, in between the insulating jacket and the bucket, the air space will be there. And the food should be weighed or measured before placing the food inside the crucible. And these two are called as the ignition wires. This will help to burn the sample which is present in the crucible. and this one is called the oxygen supply valve. Through this valve only the oxygen will be supplied into the bomb. Then if after supplying the oxygen, the ignition wire will start burning. So only the oxygen valve should be open. Other than that, all the valves which is present at the top should be closed. With the help of the oxygen and with the help of the ignition wire, the food sample which is placed inside the crucible starts burning. So before going for this burning process, we should check the volume of the water which is present inside the bucket. That is already I have told you 3/4 of the bucket should be filled with water. So this 3/4 of the bucket should be weighed. That is the water which is present inside should be measured. And not only it should be measured, the initial temperature of the water should also be noted down. This temperature of the water is noted down by using the thermometer called differential thermometer. This is the differential thermometer. So by using this thermometer, the initial temperature of the water should be noted down. Then close all the valves at the top except this oxygen supply valve. So with the help of the oxygen, now the food which is present inside the crucible starts burning. So when it starts burning, the heat will be produced by the food. So the heat produced by the food will be absorbed in the water which is present in the bucket. The heat which is released from burning of the food will be absorbed by the water which is present in the bucket. So here we can see now the temperature of the water will definitely get increased because of the absorption of the heat from the food sample. So now if you note the differential thermometer, you can see the increase in the temperature of the water. This increase is nothing but the food release some heat, and that heat will be absorbed by the water which is present in the bucket, and that increase in the temperature will be noted down. So this is the final temperature of the difference in the temperature of the water can be noted down by final temperature minus initial temperature. This will give you the difference between the temperature and the heat, how much heat is produced during the burning of the food sample. So with this we are going to see the calculation part, how by using this increase in the temperature, how the calculation can be done to find out the energy value of food. So now let's see the calculation part. The weight of the food substance taken is 2 grams. So already before placing the food sample in the crucible, the food should be weighed. It should be either 1 gram or 2 grams of the food substance should be taken. Then the weight of the water in the bucket is 3,500 grams. Already I told you the water which is present inside the bucket should be weighed initially. Then the initial temperature of the water is 24 degrees centigrade. So before burning the food sample, we should check the temperature of the water. So that is the initial temperature, that is 24 degrees centigrade. Next, after that, the final temperature of the water. This final temperature is nothing but the sample when it's burnt or when it started burning, it releases heat. So finally, the heat evolved from the food sample will be noted down, and it should be absorbed by the water which is present in the bucket. So the increase in the water or rise in the temperature of the water is 26 degrees centigrade. So now the rise in the temperature of the water can be find out by subtracting the initial temperature of the water from the final temperature of the water. So here the rise in temperature of water is 2 degrees centigrade. Then the heat gained by the water in the calorimeter is calculated by, this is nothing but the weight of the water in the bucket into 2 is nothing but the rise in the temperature of the water. So this will give you, that is 7,000 calories. So the 3,500 is the water in the bucket and 2 degrees is the rise in the temperature of the water. So this will give you the calories, how much calories is present in the food. So 7,000 calories can be converted into kilocalories. Already I have told you the unit of energy is kilocalories. So This 7000 kilocalories divided by 1000 will give you how much kilocalories. So 7000 calories are 7 kilocalories. So now you can see 2 gram of the food substance produce 7 kilocalories. Therefore, 1 gram of the food produces 3.5 kilocalories. So 1 gram of the food will produce 3.5 kilocalories. So based on this, we can derive some energy value of foods for different nutrients. So in this bomb calorimeter, the energy value derived from the bomb calorimeter is as follows. If you take 1 gram of carbohydrate, it will yield 4.10 kilocalories. If you take 1 gram of protein, it will yield 5.65 kilocalories. If you burnt or oxidize 1 gram of fat, it will release 9.45 kilocalories. So these are all the kilocalories which we can derive based on the bomb calorimeter. So thank you girls. Thank you for your patience listening.